All right, guys, welcome back. This is Ron Hackney. I'm completing up what Trent Moore had done with Module 5, videos 1 and 2, where he talked about hardnesses. What we're identifying, you guys, is the fact that every industry on every product that you build has to have a certain type of hardness and strength. Some products, they like softer products. Some products may be used where it's got to have a lot of hardness or abrasive resistance. What we're talking about in this module is what a lot of times complements hardness, which is strength. Now, the one thing that I wanted to explain, and I wrote this format down for you so you can kind of get a view of it. Strength is, if you read it out in definition, a measure to resist stress before the point of deformation. Now, let me explain what that means. I'm going to give you guys an example, and I hope this kind of helps you out. I here have a piece of filler wire, and what we're going to do is I'm going to take this fill wire, and when we talk about strength, I'm going to slowly push this filler wire down, and you're going to see that it's basically bending. Well, what happens is you're going to see that it's going to actually fold at the hand. So what we did is, as the force was coming down, that was the measure of strength. When we bent the fill wire, that's where we hit the material's yield point, or yield strength. A lot of times you'll hear it called to. So when we talk about strengths and yield strengths, that's basically what it is. It's measuring the amount of force or stress that it has to be applied to a material before it actually has deformation, okay? So now, you guys, we're going to go into the different types of strengths. We've learned in this module that every industry is a little bit different. We learned that, it depends on what we're building as to what type of strength or that we need as far as the product is concerned. So I've written down here, we got some different strengths. You have compressive strength, you have tensile strength, you have shear strength, and you have torsional strength. These are all different types of strengths that are used for different pieces or applications within our industry. We look at compressive strength. Well, anybody that's ever used anything that compresses, obviously that means it's pushing down. Some of you guys may have used our iron worker in our shop. Well, an iron worker, we know, basically replaced the drill press in our industry. It's faster, it's easier. So what happens is a die is going to come down, and it's obviously got to be a lot harder when it impacts the metal to punch a hole. So a lot of times when we talk about compressive strengths, you're looking at something that is going to punch through. It's got to be usually harder than the material that they're doing. Tensile strength, you guys, that's very simple. Tensile is like pulling apart. So to give you an idea, Trent brought up a great point. When you look at a roller coaster, we know that when roller coasters are going through all that weight and all those turns, you're going to have a lot of stresses that are pulling. As every time that roller coaster, that goes around the track, it's going to pull. So when we talk about something, a material that needs a high tensile strength, that's what we mean by that. Remember, tensile means pulling apart. Well, we have shear strength. Most of you folks have used our shear out in the yard. We use the shear to cut metal. That's why we've always warned everyone, never cut medium or high carbon steel on a shear. Those blades have got to be harder than the material. So what happens is shear strength means when two pieces come across each other. So that would be shear strength. And then, of course, torsional strength. Well, for you automotive guys, right away, I know what you're thinking, a drive shaft of a car. But remember, not everything is automotive, right? So to give you an idea, it may be a piece of bar stock that they turned into some kind of shaft for a piece of machinery on the farm or whatever. So what happens is that material has to resist the ability to twist and deform with torsional strength. So those are the type of strengths. Now, to give you guys an idea, if you really think about it though, our industry, when we build product, they may need one of these strengths to kind of stand out for the product they build. But you got to really think about it. Most of the things that we build have the majority of these strengths. If you really look around your community, you're going to find that every product that we build probably needs a little bit of all of them, okay? So that'll kind of help you guys out. Now, the one thing I want to point out to you is this. You have strength. We already understand what that is. We understand what yield strength is. That's when the metal finally breaks over and deforms, right? There's a big misconception about stiffness, and a lot of people think stiffness is like strength. Well, if you remember, when I showed you folks, here is the measure of the force or stress I put on it. Now watch what happens. I let go of it and it goes back to its original shape. See, that's where it's different. When you measure strength, you have to hit the material's deformation point to where it breaks over. So when we look at stiffness, I can apply that pressure or that stress, but I never hit the material's yield strength or yield point. So when we look at things like stiffness, it's kind of misunderstood. I wanted to give you guys an example because I think a lot of you folks can relate to this. It's something we drive every day. So when we look at stiffness, what we're talking about, I gave you an example of the auto industry. We all know that cars nowadays are made of thin sheet metal. We understand that why they do that. They do that because it's lighter. You get better fuel economy and so forth. The biggest thing I can tell you guys is they're going to alloy those steels so they can make them paper thin. That shaves a lot of the weight off. Well, what happens is when they make the material super thin and they alloy to achieve the strength that it needs. Strength can actually resist a car getting dented. How many of you guys have ever been out, you know, you're at the mall or Walmart or wherever, and somebody hits your car with a shopping cart? It's going to make a dent in it, right? So with that being said, they're looking for strength in that steel since it's so thin. Now, once you make it that thin, they alloyed it up to resist any dents that could occur. But now we run into a stiffness issue with the car panel. If you guys have ever done any kind of sheet metal work, you know if you don't rivet it down or do whatever you're going to do to hold it, it will rattle and it'll shake. So what they do is, in this industry, for instance, we've made the material thinner, so now it's lighter for better fuel economy and so forth. We've alloyed it so it's super strong to avoid dents. But now we need to achieve the stiffness. So what our industry will do a lot of times is we'll bend, or what I would tell a student, hey, go break this piece of metal. If I tell you go break a piece of metal, that means you're going to put a bend in it. Well, think about it, you guys. If I gave you a thin sheet of metal, and we took it, and let's say this metal was 4 feet long, and it was setting up on blocks right here, and I told you to stand on the middle of it, what do you think is going to happen? It's very simple. We all know it can be strong, but it's going to bend. We don't have our stiffness. We have our strength. It's probably not going to dent, but we don't have the stiffness. So what our industry will do is we may put a break down the middle of that. So in other words, you have a piece that looks like this. Now, when force is applied to it, it's got a shape. So anytime, if you ever look, for instance, at a truck bed, look at a truck bed. Why do you think that bed is not completely flat? They have a bunch of ribs in it, and they do that to be able to achieve the stiffness. They know that they have the strength, but since the material is so thin that they're trying to shave weight, they need to achieve stiffness. So what a lot of the industry will do is they're going to a lighter material, but they're putting folds, contours, and breaks in it to achieve that stiffness. So hopefully this kind of helps you out. If you really look at it, half of it is alloying and half of it is product design to achieve the characteristics that we're looking for. Now, we're going to move to malleability. Last video, Trenton was making a chisel and talking about hardness. Well, I wanted to go through here, and his was a perfect example. When you talk about malleability, you notice here I put compressive strength. What malleability is, and not all metal is malleable. Malleability works off compressive strength. So for instance, last video, Trenton hammered those chisels that he was trying to show you hardness. So I'm going to come through in here and I'm going to hammer this filler wire. Now if you look, as I was hammering that filler wire and I was making it thinner, even though I was hammering it, it's still considered compressive. So what compressive strength is the material's ability to be able to compress in thickness to a thinner component, but still not crack or chip. So not every material has great compressive strength, you guys. So we look at this. My two favorites that they say are really good, obviously, is gold and silver, and we all like that, right? So you can see how when I compress that, it didn't crack or do any kind of tearing or chipping. So this filler material would be considered good compressive strength, okay? All right, so hopefully that helps. Now we're gonna move to ductility. Ductility, a lot of people think ductility and malleability are kind of hand in hand. Some cases they may be, but what ductility is a material's ability to withstand a tensile stress. And remember what we learned about the strengths. Tensile means what? Pulling apart. So when we look, you guys, at a material, what do you think would be able to have good ductility? Well, if you look at it, when you pull something, what is ductility? It's its ability to be able to stretch without tearing or getting brittle, so you don't lose the characteristic. The best example I could probably give you is wire. If you look, wire is drawn and pulled, so it basically is gonna go under a tensile load or tensile stress. So in order for it to be able to do that and make wire that we use every day, whether it be filler wire, MIG wire, any kind of welding rod, that material would have to have pretty good ductility. A lot of times when you do that, it'll either break or become brittle. So we're thankful for ductility. So if you look at what Trent and I are covering, hardness, strength, yield strength, all these different characteristics from shear strength to torsional strength, these are all good. In a perfect world, we'd be able to achieve everything we want, but through alloying or product design, we can get a material that we can use every day without failure. So we're glad that you joined us. Trent and I, just so you know, made a video for